Algebra 3, Lesson 35, covers a few different things: changing coordinate, the name of the number, and the distance formula. Um, that's what you're seeing in 3 and 4 is the distance between two coordinates. This should be review for everybody in here, correct? So just real quick, let's go ahead and get 3 and 4 out of the way because 1 and 2 are new to you. I guarantee, I'm just certain that they're new to you. All right, so let's go ahead and see how many of you remember the distance formula. All right, I've got some geometry people in here that should have this down. We know it's the square root of something, right? What is it the square root of? X sub 2? No. Minus, okay, so we're kind of helping each other out here. Some of you remembered it was minus. Squared, okay. Plus. Okay, minus y sub 1 squared. Okay, now, x sub 2, x sub 1. I'm going to list two coordinates here, or we can even just use the coordinates we have here. -3, 6, 7, 30. Which one of those numbers is x sub 1? -3. Okay. Where is x sub 2 at? 7. Where is y sub 1? Where is y sub 2? Okay. If you know that, you should not have a problem. Now, every individual part to the distance formula is crucial to being able to solve the distance formula. Mistakes that get made. Let's go through here. I can tell you about all the different types of mistakes that I've seen. I've seen people add their x's, right? I've seen people forget to square the solutions. I've seen people subtract the x values and the y values, right? All of those types of things have happened. I've seen people that, when looking at x2, x1, actually took just a single set of coordinates. So instead of taking, say, 7 minus -3, I've seen people do something like -3 minus 6. They just put those x's and y's together and the x's and the y's together on the other side, right? Done something like that. Where we're dealing with negative numbers here, common mistake is that people will drop off the negative, right? So if it's x sub 2, 7 minus, they'll forget the -3. They'll just do 7 minus 3 instead of what should be 7 plus 3, right? Okay? So in writing up this, just to solve it, so we're already here, let's just do the problem. Okay? We should get square root of what? 7 plus 3, sure, because you're double negative. Okay? What next? Plus 30 minus 6 squared, okay? All right, let me move that down so we're not working with this. Yes. All right. So you're getting 10 squared, and then jumping to 100, okay? Plus, so 30 minus 6 was what? 24, and you're squaring 24, and that's your 576. 576. So you're getting square root of 676 equals 26. Okay. All right. We're good with this? Do we need to do the next one? Can I show you, and if you were in geometry last year, and some of you were, you might have seen me show you this, which is there another formula that I could possibly use that does the same thing? Does the exact same thing, it just does it in a little bit different order. Don't remember? Okay. Yes, you could do x sub 1 minus x sub 2 plus y sub 1 minus y sub 2, but the orders of the x's and the y's have to be the same. That's true, but that's not necessarily what I'm getting at. Okay? What I want you to understand is that let's take just a coordinate grid of where these things are. Negative 3, 6 should be like right around in here, right? And 730 is like way up there somewhere, right? And we're looking for the distance between those 2 points, correct? Okay. The interesting thing about it is that the x distance is represented here, right? And the y distance is being represented here. So if I know the distances between the x coordinates and the distances between the y coordinates, I can use the Pythagorean theorem. So the distance between negative 3 and 7 is 10. And the distance from 6 to 30 is 24, right? So 10 squared plus 24 squared equals my distance, c squared, right? 100 plus 576 is 676, right? So square root of 676 equals c, or square root of c squared. So 24 equals c. I'm not saying that it's necessarily quicker, but it does the exact same thing. And sometimes for me, because I'm just looking for the distances between the x values, I'm doing the same thing that's happening inside that square root, but I'm doing some of that in my head. So I'm not necessarily suggesting to do it this way. You should know the distance formula, okay? But I know that sometimes on a test, I know that I'm going to forget maybe the ins and outs of that big distance formula, but I know the Pythagorean theorem well enough to understand how it works, and sometimes that's all I need to get the right answer, is to understand the math behind it. Does that make sense? Okay, let me pause here for a second. All right, so you should understand, hopefully, the distance formula well enough to do number 4 probably on your own. Yes. Oh, did I write 24? That's because I forgot the answer. All right, 26. Let me fix that for. Okay, 24. I just write the same thing down again. Watch this. In red this time. Okay, 26. Okay. My brain is cooked from being gone yesterday and trying to make up today and trying to get all the homework graded and get everything set up. So yeah, no, I am not clicking on all cylinders. Okay, this next part. There is a formula to this next part. But let's see if we can get our heads wrapped around the idea first. Okay? All right, question number 1, question number 2. These are what we call the name of a number, really. This is, if you look on page 250, it's what's called the name of a number, and there's a formula for it. And it says we want to find a number that is 1/3 of the way from negative 6 1/3 to 4 2/3. So, like if we took a number line, right, and we were counting by thirds, right? So let's get 0 on here, and -1, -2, -3, -4, -5, -6, right? All right, so thirds, right, we would get, let's see, -1/3, -2/3, -3/3 would give me -1. So I could probably make a little red. And this last red tick mark would be -6 1/3, correct? Does that make sense? And then I could go over here, 1, 2, 3, 4, right? And so same type of thing. There's my thirds. And then I need, what, 2 more, right? Okay? So that I have everything written into thirds because -6 1/3 is working with thirds. 4 2/3 is working with thirds. That's fine. And so we could find the number of thirds between this point and this point, correct? By counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. There's 34 thirds, right? So if I've counted right, 34 thirds. Hopefully I haven't messed something up. So we want to find, that's my distance. I have 34. My distance is 34, right? All right. We want to find the number that is 1/3 of 34, right? Or 34 divided by 3, right? Because 1/3 of means to multiply, correct? So that'd be the same as dividing by 3. What's 34 divided by 3? Oh, you know? What's that? 11.3 repeating. So that's 11 1/3. Okay? So 11 1/3 is 1/3 of the distance, right? So what I could do from here is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 1/3, right? Okay? I'm just trying to get you to understand this visually. Okay? So that's -1, -2, -2 and 1/3, right? So does that make sense to a degree? Let's see. And I might be off because -1, -2, and I might have miscounted by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 1/3. Yep, it should be right here, which would make this -2 and 2/3. Sorry, miscounted. All right, so our answer should be -2 and 2/3, right? Could we, given enough time, figure this out? Yeah. If we forgot the formula, could I brute force math this into the right answer? Yeah? Okay. I want you to understand that you can get to the right answer. You don't necessarily have to have the formula down. What the formula does is it allows me to create a procedure, and I can memorize a procedure. But just because I've memorized a procedure doesn't mean that I understand what is happening. You follow me? Okay? So I want you to understand what is happening. That way, if I ever forget the procedure, I can still get to a solution. Does that make sense? Now, what the procedure does is it allows me in a test to get to the answer more quickly. All right. So, the formula. Can I erase this? Okay. It's in the video anyway. All right. The formula gives you something along these lines. Is that we would take our initial number. That's where we're starting from, right? So up here, my initial is my -6 and 1/3. Does that make sense? And we're going to add the amount of change that we're interested in. What's my change? 1/3, okay? And we are going to multiply that, okay, by my final number. My final number, where do I want to wind up at? 4 2/3 minus my initial number, which is, oh, I'm sorry, I need to write this up as final minus initial. That's the formula. And if I know the formula, it's going to make my life a lot easier, and it makes what seems to be a really hard problem much simpler. Kind of like our difference of two cubes. If I remember the formula is f minus s times f squared plus fs plus s squared, I'll get it right every single time. Okay, but if I forget the formula, it's going to be really hard. Okay, initial, -6 and 1/3 plus 1/3 times 4 2/3 minus -6 and 1/3. Okay? Obvious possible mistake is to forget both negatives. Okay? So be careful there. All right? So I'm going to go ahead and apply those double negatives and say 4 2/3 plus 6 1/3. Most of these that I've seen worked out tend to come up with a nice number inside. 4 2/3 plus 6 1/3 without a calculator. 11, right? Because 4 plus 6 is 10, right? We're adding nice, neat numbers. 2/3 plus 1/3 is 1. 1 plus 10 is 11. All right, so I don't know what I did there. Okay, sorry. Oh, what's that? All right. It would be 11/3. So we've got negative 6 1/3 plus 11/3. Now, good. Because I'm dealing with between a mixed number and an improper fraction, I need to get them into the same format. Because I'm dealing with negatives, I want both of them to be improper, right? Okay. So 3 times negative 8. 3 times negative 8. 18. In this case, minus 1. Negative 19/3. No. Well, I'm sorry. 3 times negative 6, which is negative 18 minus 1. I'm increasing in the negative side. So negative 18 minus 1 is negative 19. So I get negative 19/3 plus 11/3. Sorry. All right, negative 19 plus 11. What? Negative 8/3. All right, how many times will 3 go into 8? Go into it twice. All right, so 2, negative 2 2/3. Was that the same answer that we got whenever we drew it out, broke everything into thirds, found our distances in thirds, divided it by that, and then counted over? Yeah, we got the same thing. Okay? All right, let's see if you guys can do number, I want you guys to do number 2 on your own. I'll leave this up here, all right, so you know where to put things. All right, but I want to see if you guys can do this. In fact, I am going to go ahead, because I got to start being a not nice guy. Okay, I'm going to erase all of this. All right, and I ought to erase everything, but I'm going to leave you the formula.